Welcome. In this lecture, we're going to talk about how one can view the points of a line as a set in R2. So we've talked about sets a little bit, but this will give you multiple ways of looking at some of the same things to help kind of familiarize you with these definitions. So let's get started with this, right? So we can write all points on the line. So we can write all points. This is a very, very common abbreviation for points, so it's good to know that. So we can write all points on the line, and this is going to be, we're going to kind of go with our consistent color coding. So this is y equals, and then we're going to have, so here we're just going to do, so this is going to be 3, and then our input, right, so this is like our x value or y, our input or output, okay, minus 1, i.e. all solutions to the equation, and again, this is such a common abbreviation, it's good to actually make sure that you know it. So to the equation, so it's the same equation, so I'm writing the exact same thing as this. Right, these are the same thing. So we have y equals 3, let's put a minus 1 there. All equations to solution, all solutions to this equation as a set. So as a set. So let's do that. So this is going to be the set of all, right? So this is how, this notation is going to be kind of like the set of all. And then we're going to have points x, y. So we have 2 coordinates, so we're in R2, right? So this is a set of all points R2. So this is all points in R2, satisfying, right? And then it's going to be, we're going to have y is going to equal 3x minus 1. Right, and just to remind you, so what is going on there? So the way that this all works, you know, what is this all saying? So these are points x, y, and R2. So these are points x, y in R2, right? That's this part. So this part here, when we look at these together, right, this is the set of all. And then we say points in R2, and then this line here can be thought of as satisfying y equals 3x minus 1. So all together, kind of putting that all together, right, the side brackets are the set of all. This means points x, y in R2, and then we have that they satisfy this equation. So in the way to say this, so this is the set of all points. So this is the set of all points, x, y in R2 satisfying. And then we want it to satisfy this equation. Okay, but what does this really look like? I think it's important to kind of get a sense of like the picture of what's going on. Okay, so what do these points really look like? Okay, so this is, we're going to draw this over on this side over here. Okay, so we have, as typical, so we have our x-axis like this. So this is our x-axis, and then we have our y-axis. Right, and then we have, so right, this gives us the intercept. And I'm actually going to just do this in red because this is the color that's left. This gives us the intercept and the slope, right? So we know that this kind of goes through minus 1. It has a slope of 3, so it's steep. And it's a positive slope, so it slopes upward as we move to the right. Okay, so this is the equation here is y equals 3 x minus 1. I forgot to label my y-axis here. Okay, so what if I look at an individual point on here? An individual point on here is going to look like, so if I took some point on here, it's going to look like, well, generically, it's going to look something like x, and then, you know, we would put it into there, and so, right, so it's generically, it looks like xy, but a particular point on there, so maybe, well, the scale is a little bit, okay, no, that actually kind of works. So one could look at the point here, so in particular, one of the points on here would be 1 and then 2. Which we can check in a minute that this, what is, okay, so what is this line? So this line contains all the points that are in this set, okay? So this line contains all points in the set that we were looking at before, so this set right here. And R2 satisfying. I'm just saving myself a little time there by doing everything with the same color at the same time. Right, so it's everything satisfying y equals 3x minus 1, so it's precisely this set, i.e. all points, right, xy satisfying the equation and then again, this is the same equation that we've been talking about, so it's going to be y equals 3x minus 1. X. Okay, so we want to check this. So I said that this is a point on the line, so let's check that. Okay, so let's check. So let's check that actually a point on line. Okay, and so what we need to do is we need to actually stick this into the equation. Okay, so I'm going to put it in on that side and make sure I get 2 out, right? That would mean that I could put 1 in here and get 2 out there. That's what it would mean. So let's go ahead and check this. So if I take 3 times, and when we do kind of our parentheses trick, and then everywhere we see an x, we want to put in 1. Okay, so we have 3 times 1. So that's just 3 minus 1, and what do we get out? We're very happy because what we get out is that we actually get out 2. And so this does indeed satisfy it, right? Because those are the same. So the 2 sides are the same, so it satisfies. So these are the same. So our point 1, 2 satisfies the equation to be on line. Satisfies the equation to be on the line. Or contained in that set, right, which is the same thing as a line. Okay, so this was again our point 1, 2. Okay, so let's just kind of recap what we went over here. So we're talking about the fact that this line, like the line we always think of as a line of y equals 3x minus 1, it's actually precisely the elements of this set, right? Because these are points in R2, so they would live in this picture. But they're the ones that satisfy this equation. And you can even check that, right? So if I had a point on here, how would I check that? I would actually plug it into this equation, right? This equation that we're seeing in this set, which is the same equation as the line equation. And we check that when we stick it in on, you know, when we stick things in, so 1 for x and 2 for y, when we stick those in, we do actually indeed get the same thing on the left and right when we stick those into our equation. Okay, so I hope that made some sense, and I'll see you in the next lecture.